My topic for tonight is about solutions. I'm going to define first what is the meaning of solution, then the characteristics of solution, the examples of solution, then the different types of solution. A solution is a homogeneous mixture of two or more substances. A solution may exist in any phase. A solution consists of solute and solvent. The solute is the substance that is dissolved in solvent. The amount of solute that can be dissolved in solvent is called its solubility. Now I'm going to talk about the characteristics of solution. A solution consists of homogeneous mixture. A solution is composed of one phase, that is solid, liquid, and gases. Particles in a solution are not visible to the naked eye. A solution does not scatter a light beam, and components of a solution cannot be separated using simple mechanical filtration. Any substances which can be evenly mixed may form a solution. Even though material of different phases may combine to form a solution, the end result always exists of a single phase. For example, a gas-to-gas type of solution is equals to air. A gas to liquid type of solution is equal to carbon dioxide in soda, and a gas to solid type of solution is equal to hydrogen gas in palladium metal. Solutions are categorized based on the following. First type is based upon the solution of solute in the solvent. Depending upon the dissolution of the solute in the solvent, solutions can be categorized into a supersaturated solution, which comprises of a large amount of solute at a temperature wherein it will be reduced. As a result, the extra solute will crystallize quickly. An unsaturated solution is a solution in which a solvent is capable of dissolving any more solute at a given temperature. A saturated solution, on the other hand, can be defined as a solution in which a solvent is not capable of dissolving any more solute at a given temperature. The solutions are made up of two forms, depending on whether the solvent is water or not. First is aqueous solution. When a solute is dissolved in water, it is called aqueous solution. Examples are salt in water, sugar in water, and copper sulfate in water. Second is non-aqueous solution. When a solute is dissolved in a solvent other than water, it is called non-aqueous solutions. Examples are iodine in carbon tetrachloride, sulfur in carbon disulfide, and phosphorus ethyl alcohol. Solutions are categorized based on the amount of solute added to the solvent. Number 1 is dilute solutions, and number 2 is concentrated solutions. A dilute solution contains a small amount of solute dissolved in a small amount of solvent, while a concentrated solution contains a large amount of solute dissolved in a small amount of solvent. What are the factors affecting solubility? Nature of solute or solvent, like dissolves like. Polar solute dissolves in polar solvent, while non-polar solute has a low solubility in polar solvent. Example, a non-polar solute like fat grease is soluble in soap, which is a non-polar solvent, while on the other hand is insoluble in water, which is a polar solvent. Another factor that affects solubility is temperature. For solid solutes, as temperature increases, solubility increases. For gas solutes, as temperature increases, solubility decreases. The third factor that affects solubility is pressure. For solid solutes, as pressure increases, solubility remains the same. For gas solutes, as pressure increases, solubility increases. My next topic is about mixtures. Mixtures can be classified as homogeneous and heterogeneous mixtures. Mixtures is composed of two or more substances, but they are not chemically combined. In contrast, the compound contains various elements that are bonded to each other. A mixture is what you get when you combine two substances in such a way that no chemical reaction occurs between the components, and you can separate them again. Examples are mixtures of salt and water, sand and water, ethanol in water, and salt and pepper. A homogeneous mixture has a uniform composition that doesn't readily separate. Hence, the resulting substance consists of a single phase. Examples are air and saline solution. The solute in air include oxygen, carbon dioxide, and water vapor. The solvent in the air is nitrogen, while saline solution is simply salt, which is the solute, dissolved in water, which is the solvent. A heterogeneous mixture, in contrast, that does not exhibit uniform properties. It's often possible to see the particles in the mixture and separate them from one another. Examples of heterogeneous mixture includes a wet sponge, sand, gravel, trail mix, and chalk suspended in water. One way to describe the concentration of solution is by percent of solution, that is composed of solute. The percentage can be determined in two ways. Number one is mass percent. The mass of solute divided by the mass of the solution. The formula is percent by mass is equal to mass of solute over mass of solution times 100%. The second one is volume percent. The volume of solute divided by the volume of the solution. The formula of volume percent is percent by volume is equal to volume of solute over volume of solution times 100%. Concentration of solute in a solution can be expressed as percent by mass, percent by volume, molarity, and molality. Percent by mass is equal to mass of solute over mass of solution times 100%. Percent by volume is equal to volume of solute over volume of solution times 100%. Here's an example of calculating the percent by mass. Number 1. Calculate the percent by mass of solution prepared using 25 grams of sugar dissolved in 100 grams of water. The following data are given. Mass of solute is equal to 25 grams. Mass of solution is equal to 100 grams of water plus 25 grams of sugar. Then solve the percent by mass. Percent by mass is equal to 25 grams of sugar over 125 grams of solution times 100%. The answer is 20% of sugar. Here's an example of calculating the percent by volume. If a solution is made by taking 40 milliliters of ethanol and adding sufficient amount of water to make 240 milliliters solution, calculate the percent by volume. The following are the given. Volume of solute is 40 milliliters. Volume of solution is 240 milliliters. Then solve using the formula of percent by volume. Percent by volume is equal to volume of solute over volume of solution times 100% equal to 40 milliliters of ethanol over 240 milliliters of solution times 100%. The answer is 16.7% ethanol. The following can also be used in the computation of concentration based on moles. Molarity of a solution is the number of moles of solute dissolved in 1 liter of solution. Molarity can be computed as moles of solute over liters of solution. Here is a sample problem to show how molarity is computed. A solution is prepared by dissolving 42.23 grams of ammonium chloride into enough water to make 500 milliliters of solution. Calculates its molarity. The following are the given. Mass of ammonium chloride is equal to 42.23 grams. Molar of ammonium chloride is equal to 53.50 grams per mole. Volume of solution is equal to 500 milliliters or 0.500 liter. The mass of ammonium chloride is first converted to moles. Then the molarity is calculated by dividing the liters. Conversion of the mass of solute to mole. We have 42.23 grams ammonium chloride times 1 mole ammonium chloride divided by 53.50 grams ammonium chloride is equal to 0.893 moles. Then using the formula of molarity, the number of moles of solute is equal to 0.893 moles. divided by the liter of solution, which is 0.5 liter. The answer is 1.579 molarity. Molality is the moles of solute divided by kilograms of solvent. Here is an example of a problem. Computing for molality. Determine the molality of a solution prepared by dissolving 28.60 grams of glucose in 250 grams of water. The following are known. Mass of solute is equal to 28.60 grams. Molar mass of glucose is equals to 180.18 grams per mole. And mass of solvent is equal to 250 grams or 0.250 kilograms. First, you have to convert grams of glucose to moles and convert the mass of the solvent from grams to kilograms. Here's how. 28.60 gram of glucose times 1 mole of glucose divided by 180.80 grams of glucose is equal to 0.1587 mole glucose. Then use the formula of molality, that is moles of glucose, which is 0.1587 mole divided by kilogram of water, which is 0.250 kilogram. The answer is 0.635 molality. Now let me touch on the colligative properties of solution. Colligative properties are physical properties of solution that depend on the concentration of the particles and not on the kind of particles. These properties include the elevation of boiling point, the lowering of freezing point, a reduction of vapor pressure, and osmotic pressure. Consider vapor pressure. Pure solvents that evaporate more easily exhibits higher vapor pressure than those that do not. Alcohols tend to have higher vapor pressure than water. If you add solute to a solvent, this impedes the evaporation of solvent, thus reducing the vapor pressure of the solvent. If you lower the vapor pressure, then the solvent will boil at a higher temperature by adding sugar or table salt to water. You will elevate the boiling point of water. Similarly, the pure solvents will freeze at lower temperature. By adding solute, water will freeze below 0 degrees. Osmotic pressure is greater for solution with dissolved solutes than pure solvent. This is why salt is bad for people with hypertension, because it raises the osmotic pressure within blood vessels.